But Hiroko Yoshida is with Centrisys, and we're going to let you take over. And if anyone needs a mic, I'm going to go check into whether we can get one, because I know your voice is a bit.
Can you hear me okay?
Yeah.
In the back there? Okay. I'll do my best. Can I start? Okay. Thank you so much for inviting us over to Waste to Worth conference. I learned so much from this conference, and I'm representing actually two companies now, that Centrisys and CNP. CNP is a division, Centrisys is a company focused on manufacturing of decanter centrifuge, and the CNP is focusing on carbon, nitrogen, and phosphorus, the nutrient recovery. So what we really do is the manual solid separation, actually solid separation, because it brings up lots of benefits, as everybody is aware, that it will decrease the frequency of dredging and also make it easier to transport or store manure. But increasingly, we are asked to do is nutrient management, because as much as 70% of P and 50% of nitrogen in manure is present in a particulate, like non-dissolved form. So this is just to give a little information about what decanter centrifuge does. It's a continuous process. We feed manure that our machine spins very fast, 3,000 RPM, and use a centrifugal force to separate even the fine solids from the liquid. And I just want to give one thing. Everybody thinks that the centrifuge uses a lot of electricity. If you calculate, it's that the 3 to 4 cents per cow per day. So if it's 3,000 daily cow operation, the annual running cost is around $30,000 on electricity. So it's not as bad as people think it is. I just wanted to throw the number. Then, we do have experience working with manure since 2000. So we've been around this business for a long time. So we're a little bit hesitant to say we are innovators. But for daily manure, like actually choice of the solid separation technology is very critical, because the phosphorus tend to bound to be a very fine particulate form, less than 125 microns. So some of the conventional technologies like screens and screw press cannot handle the particulates this small, so it goes to here. So this is the data we collected, and we've been running a pilot test and then full-scale installation site. And these are the actual data collected at this site. So as you can see that the bottom is a screen, and then screw press. They do great at solid removal, but as you can see that there is a limit on how much phosphorus they can take out. And so what centrifuge can do is that we can increase the solid separation, but we can almost triple the phosphorus separations. And so it's also, I want to point out that we've been moving to this direction because we are constantly changing the geometry of the centrifuge to actually fit to manure, because we realize the manure and human manure, it's totally different. So if you come to visit our site in Kenosha, I'll actually open the centrifuge and show you that the difference in the cone geometry that will allow us to do a good separation. We're not gonna say we made everybody happy, but yeah. So then we also did a study in swine manure. And it was actually, we had I dug up a study, happened in 1999 and 2000, actually done with North Carolina State University. So I'm looking for somebody who remember this. That we went to Lagoon. We took the Lagoon bottom sediment, and then we took this the portable, mobile centrifuge units to dewater the bottom sediment. And so for this one, we did use a polymer, and then we can actually produce spotlessly clear centrate. And so these are the data that we can get if we use polymer product. And so from Lagoon sludge, we can get around 24 to 25% solid. And then this is flash waste, we can go up to 34%. And the one thing is that we can actually get this high of the solid without using polymers. Only difference is that we don't get this like crystal clear water that the research project needed. But if somebody is interested in trying this again, we are more than happy to send our mobile units and the boys to actually stand in a lagoon. So then the last nutrient recycling challenge came in because we live in Wisconsin, so phosphorus is a nemesis. So if that's the material, we are always asked to go down as low as possible. And then what we thought is, okay, the centrate still have this much phosphorus. If we can deplete this, we can apply more on the land through irrigation. So that was the whole idea, that let's do more to tackle the dissolved portion of the phosphorus.
They're having trouble hearing you in the back because of all the noise in the hallway.
Excuse me, everyone.
Thank you.
All right, so we got one.
More and more professional every moment.
Every moment. What's day 4?
Can you hear me okay better? Okay, perfect. And so then what we try to do is like, let's turn the dissolved component into a solid. If we cannot capture the dissolved component, let's just turn it into the form that the centrifuge can capture. So what we did is, so the studiovite is a crystal of ammonia and magnesium phosphate, and known as a luisance because it causes a clogging of the pipes, which some of you might be familiar, but it also causes dewatability problem, especially in the municipal wastewater business. And but in a controlled environment can be harvested as a fertilizer. And so what we try to do is that we try to bring this MagPrex system, which is developed for human wastewater treatment plant, to the area of agricultural production system. So MagPrex utilizes aeration, not caustic soda to elevate pH. So only thing we dose is actually de-icing salt, and feed with a solid content up to 5%. So we can actually go before the decanter centrifuge to turn the dissolved phosphate into a particulate crystal form. And it's been implemented successfully in a municipal wastewater treatment plant. So it's like, it's innovation, but it's somewhat proven technology. So this is what is proposed. We should be like in between anaerobic digester, but looking at the lagoon, we can probably work without anaerobic digester as well. So then MagPrex reactor, and then it will come with decanter centrifuge, and then about 50% of the studiovite crystallized can be harvested as studiovite. So for that, we are still looking for the system that can be compatible with this to remove ammonia, because the centrifuge can create a crystal clear centrate. So any kind of ammonia removal system could work better if we can put right here in a centrate line. And membrane technologies, because we also depleting a lot of carbon dioxide, the pH is already high. So if any of your person if we can tag up and then do this project happen together, take my card. And so that was one thing we're really interested in. And just to add a couple more about recent development, One thing is that so we modify a centrifuge, and we now call it DT centrifuge. And we actually did a 7 daily firm pilot test in British Columbia, like ranging as small as 300 daily cal. And no chemical addition, because this is what we were asked to do. And then we are achieving at least 50%. And actually, we can achieve up to like 70%, but we are asked not to use the number because it was too high. And then the consultant who actually collected sample and did the testing said that he's not comfortable yet. But we can do it. We are allowed to say 50%. And then the great thing is like 200 daily farmers show up for the open house, and we are like, oh, nice. That was very nice. And then the second thing is MagPrex. We actually made one. Developed the 10 gallon per minute mobile pilot reactor. We toured it around 7 pilot test sites all over the United States, from Miami to Pima County to Denver to Sanford, Wisconsin, which is a small site. And the great thing is that based on that, full-scale installation is coming up this year. So if you, later this year, like around winter time, if you are around Maryland or Ohio, Cleveland, please come and join us. We can show you how it works in the large scale in human poop. And the last thing is we actually acquired one more process from University of Wisconsin, Madison, that is actually complementary to our MagPrex process. So it's a calcium-based process, small reactor. It requires centrifuge. It's a little bit complicated than MagPrex, so if you have interested in, let me know. And that we are actually doing a pilot test in Woodbridge wastewater treatment plant just outside of Chicago. So again, if you are in Chicago area, give me a call. I'm more than happy to tour the site. So any of these questions, please let me know. And then I also, again, we are looking for somebody who can buy our centrifuge, but also we are looking for somebody who can put their ammonia removal technology on our centrate line to actually make it adaptable, not only in Wisconsin, but the area that the nitrogen is the limiting factor for manual application. So that is said, do you have any questions?
The 2 systems that you're putting in,
Yeah.
Are those municipal or are those livestock related?
So this one, this will be a wastewater treatment plant. So one process will be, so both of them a wastewater treatment plant, and then, I can't remember the size at the top of my head, but if you can have your card, I can forward the information.
I'll get you later.
Yeah. Yes.
Your demo scale pilot reactor, has that been tried on other manures, swine?
That is one thing that we need a little bit of financial assistance for. So for this one, we made for wastewater treatment plant. So that in order to adapt to the manure, we need to put some kind of screening process to, because if we feed like really fibrous material, it's gonna be wrong. So that was a part that we need to develop. That will be the innovation comes in. And again, if you have any money to work on this part and push the limit of the reactor, I input on this. Yes.
Any other questions? Anyone have money?
Yeah. Yeah. It's one thing. We have a reactor, but moving this reactor is a little bit expensive. So again, if you have a $20,000 to move this reactor, I mean, we can go anywhere in the United States. Shipping to Canada was really hard. So, yeah.
Okay, well, thank you, Haruko.